This last one, we've got the square root of 2x plus 1 equal to 3 plus the square root of 4 minus x. We notice that there are square roots on both sides of the equal sign that we have to consider when we are when we're solving this. Now, it doesn't matter which one we isolate. I already see that the square root of 2x plus 1 is isolated, and so we'll take care of that one first. We're going to have to isolate more than one time. We'll have to square more than one time because we need to get rid of that second side as well. So I am going to start off, since one of them is already isolated, it doesn't really matter which one, when you encounter this, is isolated at all. So when I take the square root, then I know that the square root and the square eliminate each other. So I have 2x plus 1 equal to, and then I know that this part on the right hand side is going to be multiplying it by itself twice. So I'll have 3 plus the square root of 4 minus x times 3 plus the square root of 4 minus x. We will have to distribute. So we're going to do that. I know that 3 times 3, of course, gives us 9. Then I'll have 3 times the square root of 4 minus x, so plus 3 times the square root of 4 minus x. Oh, thank you for letting me know that Josie's here. I'm not taking attendance. So many of you are gone. We're not going to worry about attendance today. But I really appreciate you sharing that. When I do the inside, I'll have another 3 square roots of 4 minus x. And then what we'll have, we know that underneath these pieces here are 2 binomials, and when I multiply 2 radicals, remember our rule from earlier, if I have a times b, the radicals are multiplied, then I can squish them and multiply a times b on the inside. So when I do that here, this would be the same thing as saying the square root then of 4 minus x, because that's the inside, the radicand of the first one, and we have the radicand of the second one as well. But also, I see that I have something multiplied by itself. So we went from 2 things being multiplied came from this piece here squared. So I could work backwards. I know that 4 minus x times 4 minus x is in fact 4 minus x squared. So I'm going to take it one step further to help with the simplification. So I'll still have that 2x plus 1 on the left. I know that I'll have 3 plus 3, so I have 6 square roots of 4 minus x plus the square root of 4 minus x squared. Well, we know that when we have a square root in a square, they eliminate each other. So that was the purpose of wanting to write this as one square versus just 2 pieces here, because then we're able to eliminate one of the radicals. That's kind of the idea here. So I've got 2x plus 1 is 9 plus 6 square roots of 4 minus x plus 4 minus x. Now, it might be useful to get everything, all the common terms together on one side before we start moving and isolating, so that you're not doing too many steps at once. But if you can combine those steps, you're welcome to do so. I know that I have 9 plus 4, so that's 13. And then I have minus x plus 6 times the square root of 4 minus x. Our goal is to isolate, because there's nothing else that we can do but isolate the radical so that we can square again. So to do that, I'll have to subtract 13 and add x and bring that to the left-hand side as I start isolating that radical. I now have 3x minus 12 equal to 6 times the square root of 4 minus x. I can divide both sides by 6, although it kind of will be weird because I'll have fractions, it won't be too big of a deal to have fractions because it's a nice fraction. Half x minus 2 is the square root of 4 minus x. And now that we have the square root of 4 minus x isolated, we will want to square again to get rid of that last square root. So yes, I will have to expand again. I know that half x minus 2 squared is the same thing as saying half x minus 2 times itself equal to 4 minus x. Let's go ahead and distribute. We'll be very careful here as we do that. I know that half times half, of course, is 1/4 x squared. Then I'll have half times negative 2, so minus x. Half times negative 2 again is another minus x. And then negative 2 is positive 4, is 4 minus x. Combine like terms. I've got 1/4 x squared minus 2x plus 4 is 4 minus x. Because we have a quadratic, we might need to consider factoring. So I'm going to subtract 4 and add x so that we set it equal to 0. I'm going to need some more space here. This will then be 1/4 x squared. If I add x, I'll have subtract x, and then 4 minus 4 gives me 0, so this is equal to 0, which works out nicely because the only thing I have is a greatest common factor of x. When I factor the greatest common factor, then I'm left with 1/4 x minus 1 set equal to 0. And then we set each factored piece equal to 0. So x could be 0, or 1/4 x minus 1 is 0, where I would add 1 and multiply by 4, so x could be 4 as well. Just like we did yesterday, once we got to this point, we know that there could be no solutions, there could be one solution, or both of them could work. So we do have to check our work. So let's check back in the original and see which one, both, or none. So let's start with 0 since that's kind of the easier one. So is the square root of 2 times 0 plus 1 equal to 3 plus the square root of 4 minus 0? So I've got the square root of 1. Is this equal to 3 plus the square root of 4? Not happening, right? Because I know the square root of 1 is 1, and here I have to take 3 plus more. It's going to be way over 1, so this one doesn't work. So 0 is not a good solution. Let's double check 4, and then we'll show the graphing portion, which you probably can already foreshadow if you have the notes printed out. I have the square root of 2 times 4 plus 1 equal to 3 plus the square root of 4 minus 4. There we go. So I've got 2 times 4 is 8 plus 1 is 9. So is the square root of 9 equal to, well, 4 minus 4 is 0. The square root of 0 is 0. So the square root of 9 is in fact 3. So x equals 4 is a good solution. And now let's verify that using graphing technology. The first one, of course, that we covered yesterday was the intersect method, where I set the left side equal to the right side. Notice I didn't change anything, I didn't move anything, I just equaled the left and the right and found out where do they intersect, where do they cross each other. And we say that that is in fact at 4. Okay. The other way is the x-intercept, where we set the equation equal to 0. So to do that, I took the right side and subtracted it and brought it to the left side. So I subtracted 3 and subtracted the square root of 4 minus x and said, well, since this is our y value, what is our x value that makes our y value 0? And in fact, 4. Either method works because either method will give you that gray dot on the graphing tool that we can touch and find the solution. But it's a great way for us to double check our work. It's also a great way, just like that last example we did at the end of the day Tuesday, the end of the lesson, where we had to find the exact solution, but decimals always gives us um, the the decimal solution. And sometimes my open math wants the exact one, but it's a way to help double check our work, make our life a little simpler, a little peace of mind, if you will.